Assalamu alaikum. In the first video of this week, we had a look at the scatter plot to identify and study the relationship between two variables in bivariate analysis. In this video, we are going to have a look at the two numerical measures that quantify the relationship between two variables. Covariance is the measure of joint variability of two variables. It tells the direction of the relationship, but it cannot identify the strength of it. This is the expression to compute covariance between two variables, and we can see that it is measured the variability of two variables as a joint value. So we identify the deviations of x from its mean and the deviations of y values from its mean. The product is taken, the values are summed up, and we average this out to find the covariance between x and y. Covariance is used to compute the correlation. Correlation is a measure which can identify not only the relationship, the direction of relationship between two variables, but also its strength. The correlation coefficient quantifies the strength and direction of linear relationship between two variables. It ranges from -1 to 1. 1 indicates a perfect positive relationship, -1 indicates a perfect negative relationship. 0 indicates no relationships. If we observe a correlation coefficient of plus 0.8 between hours of study and exam scores, it suggests that there's a strong positive correlation between the two, which means that if the study hours increase, the exam scores also tend to increase. Conversely, a correlation coefficient of -0.7 between the number of hours spent watching TV and CGPA indicates a strong negative relationship, as this means that as the TV watching hours increase, the GPA tends to decrease. Consider this example. Here you can see different scatter plots, and with those, signifies the kind of correlations the variables modeled represent. So for a perfect linear relationship that you can see here, although of course there are some dots which are away from the line, but the pattern is very clear. This is a strong positive relationship. Why is it strong? Because the dots are clustered together and they make a definite pattern. And why is it positive? Because with the increasing values of x, the values of y are also increasing. This one shows, let's move on to this one first. Here we see a positive relationship because with the increase in x values, there is an increase in the y value also. But we see that the dots are not quite closely clustered. So this is a weaker positive relationship. Here you see a strong negative relationship because the pattern is quite definite, quite well-defined. The dots are quite clustered together. And why is it negative? Because with the increasing values in x, the values of y are decreasing. So this is a strong negative correlation. In this graph, we see a negative correlation, but it is not as strong as this graph because the values, they don't seem to be clustering together closely. And there we can see scatter in these dots. So this is a weaker negative correlation. Here we see that we can see the dots which are clustered, but the pattern is not very well defined because you still can see some scatter in the scatter plot, and this represents a moderately negative correlation. Why is it negative? Because with the increasing values of x, the values of y are decreasing. And in this plot, you cannot possibly identify any pattern. So this represents no correlation, which means there is no relationship between these variables which have been modeled in this graph. If you look at this table, you will find the guidelines for strong and weak correlations. If you have values of correlation coefficients ranging from 0 to 0.1, this is a negligible or non-existent correlation. If the values are in this range, 0.1 till 0.39, this represents a weak correlation. And also please note that these are the absolute values. If it is a -1.1 till -0.39, it is a weak negative correlation, and otherwise it is positive. And here we are discussing the absolute values. So if we have this interval of correlation values, 0.4 till 0.69, this represents a moderate correlation. Finally, we have the strong correlation categories as 0.7 to 0.89 for strong correlation, and very strong or nearly perfect correlation if the range is from 0.9 to 1. One thing that we must emphasize here is that correlation is not causation, which means that a change in the independent variable brings about some change in the dependent variable, but it does not cause the dependent variable to happen. For example, the sales of ice creams and the electricity bills can show a positive correlation, but one does not cause the other. Increase in the sales of ice cream is not the cause of increase in the sales of electricity bills. Rather, both of these are caused by a third variable, which is the heat. So we must emphasize that correlation is not causation. The two correlation measures that are commonly used are Pearson correlation coefficient and Spearman correlation coefficient. Pearson correlation coefficient measures the strength of the linear correlation between variables, whereas the Spearman correlation coefficient can measure the nonlinear correlation between variables, and it can do this because it makes fewer assumptions about the distributions of the data set. If we remove the outliers from the data, the values of both Pearson and Spearman correlation coefficient, they come out very close. This is the expression to compute the Pearson correlation coefficient, which is normally represented by the symbol, this symbol R. Essentially, this is a small gamma in the Greek, but usually you will find it represented as R. And this is the expression that is used to compute the Pearson correlation coefficient. Here you can see that the numerator is very similar to what we saw in covariance. So it computes the deviations of x with respect to the mean of x and deviations of y with respect to the mean of y. The product is taken and it is divided by the squared deviations of these variables from their means. This is how we compute the Pearson correlation coefficient. And once it is computed, we can use the guidelines given in the previous slide to identify whether the relationship is strong or weak, or whether it is positive or negative. This value, whatever this value, which ranges from -1 to 1, measures the variation in y with respect to the variation in x.